Hello students, this is the second class of units and dimensions. In the first video what we have studied about what is units and what are physical quantities, what are the types of physical quantities. There were three types of physical quantities, right? Fundamental physical quantities, second one was derived physical quantities, and third one was supplementary physical quantities. And the next topic we have studied is dimensions, right? In the dimensions we have find out dimensions of many of the physical quantities, right? Yes. So now we are starting with next topic in the dimensions itself, that is principle of homogeneity. So our topic is now principle of homogeneity. Correct? What is the principle of homogeneity? Here the dimensions of each term of an equation must be same. Suppose there is an equation given to us, so we can write the dimensions of each term of an equation must be same, right? That is, suppose there is an equation like this, some term is there plus this minus this is equal to 0. Suppose this is the equation given to us. So the dimensions of this term and this term should be same. Or we can write, we can add and subtract similar physical quantities. We can add and subtract similar physical quantities, right? Like we can add 4s plus 2s. This is feasible, right? If we have to write 4s plus 2 kg, we can add them? No. So this is the principle of homogeneity. Understand? Suppose we have a question, for example, find the dimensions of A and B in the equation V is equal to A plus BT. Okay, where V is velocity and T is time. So this is a kind of equation, right? So how we will solve this equation to find the dimensions? So we can write dimensions of A will be equal to dimensions of V okay. So dimensions of A will be, what is the dimension of E? Velocity, that is distance upon time. So from here the dimension of A will be m0 l1 t minus 1, right? So this is the dimension. From here we can find the dimension of b as well. What will be the dimension of b? It will be dimension of v divided by dimension of t. So v will be again lt minus 1 divided by t. So what will be the dimensions of b here? That is m0, l1, and t will be minus 1 and minus 1. T will be minus 2 here. So these are the dimensions of b. Correct? Yes or no? Yes. So this is the principle of homogeneity, right? Next topic we have here is dimensional analysis, because we have to find the relations between physical quantities using the dimensional analysis. We will be doing more questions. First we should understand what is the dimensional analysis. So next we are doing dimensional analysis. For dimensional analysis, we have to derive the relations between the physical quantities. So, deriving the relations between physical quantities PQ we can denote using the dimensional analysis. DA, right? For example, we can have a question. Force F on a particle depends upon first mass m of the particle, and second one is acceleration of the particle. Okay, so we have to find the expression for force. Force F. So what will be the solution? How we can find this? So deriving the relations between physical quantities, first we have to write which quantity is depending. So F is depending here firstly on m, that is mass. We can write m raised to power x. Then force is also depending upon acceleration. We can raise it to power y. If we are combining these two, F proportionality sign will remove, a constant will come, k m raised to power x, a raised to power y. Correct? K here is dimensionless. Okay, proportionality constant, because proportional sign we have removed, so it is dimensionless proportionality constant. Okay, now we can find the dimensions. So what we can write is dimensions of f is equal to dimensions of m raised to power x, dimensions of a raised to power y. What is the dimensions of f? You know, force is mass into acceleration. So that will be ml t minus 2. So we are writing the dimensions ml t minus 2, right? It will be equal to m raised to power x. And what are the dimensions of acceleration? L t minus 2 power y, right? So we can write ml t minus 2 is equal to m raised to power x, L raised to power y, t raised to power minus 2y. Okay. Now comparing on both sides, what is there here? m1 is equal to m raised to power x. So x will be equal to 1. L1 is equal to L raised to power y. So y will be equal to 1. Okay. And if we can compare with t also, minus 2 is equal to t minus 2y. So it will be minus 2 is equal to minus 2y. Y will be equal to 1 from here as well. So we have x is equal to 1 and y is equal to 1. Substituting in this formula for f, what we have calculated, f is equal to k m raised to power 1 a raised to power 1. This proportionality constant is 1, so f will be equal to ma. This is the formula of the force. So with this type we use dimensional analysis.